Ma'am, you are not audible. Ma'am.
Ma'am?
Ma'am, you are on mute.
Ma'am, you're on mute. Ma'am, you're on mute, ma'am.
Now?
Yes, ma'am. Yes, ma'am.
Okay. So, for competitive level, so far I have taken NEET, right? For IIT JEE, it will be around 2 questions from solution chapter. In NEET point of view, in IIT point of view, like, 2 questions. If you clearly understood the concept, if you're clearly able to solve the questions. So I have incorporated many problems. Okay, your exercise problems. So try to solve it, and also I will also help you. It will take around 5 to 6 classes to complete solution. Okay, not 1 or 2 classes or 3 with the problems. If it is not problems, means 4 chapters, 4 classes is enough. How can we do? With problems shall we do it? Okay. So from the word solution itself, you can see what is solutions first of all. Medium. Then solute plus solvent. So solute plus solvent is a mixture of solution. Okay. So this is your mandatory. So there is 2 types of mixtures is there. That is homogeneous mixture and your heterogeneous mixture. Okay. So these are all the basic things I'm trying to brush it. So homogeneous mixture means what? One type of particles, which means uniformly distributed. Any other answers?
Light can pass through.
Like a?
Light can pass through.
Okay, light can pass through a solution. I think you're speaking about colloids, emulsion, suspension, Tyndall effect. You're coming to that thing. That is XII chemistry. This is solutions. Just think at a very basic level. So homogeneous mixture and heterogeneous mixture means both of the solution, both contain solute and solvent. Okay, so in this homogeneous mixture, the solute will be completely dissolved in this one. Okay, how? Can you say any example? Salt and sugar water. So when you're adding, okay, my question is okay. You're saying sugar with salt, sugar and water, salt and water, they're completely dissolving, completely they're getting ionized. So in water, the particles, the intermolecular particles, like quite moderate. I'm not saying completely far away from each other. In gas only it will be far away from each other. So quite it will be like moderate. In solids it's slightly packed. So when you're stopping the sugar, you're saying it's completely dissolving. So what the sugar particles will, what will happen to the sugar particles? Huh? NaNC, you're saying it will be dissociated into ions. That's fine. So I'm asking, okay, so your beaker is there, your water is there, they're completely dissociating. The sugar will be completely turning into liquid. Exactly, very good. So what happens? See, in water there is quite a moderate intermolecular spaces there, no? So the sugar particles will go and fill the spaces. So what happens? It will be completely getting dissociated, completely getting dissolved. Dissociation or this nothing but ionizing. So the solute will be completely ionizing in the solvent. The solute is completely dissociating. Okay. So sugar in water, salt in water, everything follows a similar pattern. So this is a homogeneous mixture. And always just do remember, and your lemon water, lemon juice, everything. And in heterogeneous mixture, it will exactly sand and water. So what happens to the sand and water? You can see, you can't say 100% it's not soluble. Some sand is quite soluble. The impurities and the sediments will be settling at the bottom of the beaker. So what happens? The solute is not completely ionizing. Correct? So it is not completely dissolving. That is your heterogeneous mixture. So homogeneous mixture is completely dissolving. Heterogeneous mixture is what happens? It will be not completely ionized. So in solution, you are not going to study about the heterogeneous mixture only. Full and full, you are going to study only about the homogeneous mixture. Okay. So your book, there is a first heading that is known as binary solutions. What is binary solutions? Bi means two. So always binary solution refers to a homogeneous mixture. Okay, where it contains of solute and your solvent. Clear? Yes. So coming to our next one. So there is a formula for a binary solution also. It is nothing but your solute and solvent. Got it, this one. Now, next question. How will you identify this one is a solute, this one is a solvent? Don't say water is a solvent. Please. Yes. Exactly. So the substance which is present in less quantity is solute. Okay. Which is present in more quantity is a solvent. And then one more thing. Any other property?
Dissolves.
Yeah, you're close, but I need a dissociation constant. Okay.
Substance is dissolved is solute.
You are right. You are also right. Shall I explain with my term? Okay. So this is solute. Okay. What happens? Okay. So here you can see it is present in lesser quantity. Here it is present in more quantity. Another term you said about the dissolving and dissolution. There is a term. Okay. The physical state that is completely getting changed once after you are adding to the solvent. That is your solute. Correct? Say for example, you are adding sugar. Before adding sugar, sugar is a solid. Okay. Once after you are adding to the solvent, it is completely changing its physical state from solid to liquid. So once it is changing its physical state, that is your solute. Solvent, it won't change its physical state. Water is before also it's a liquid, after also it's a liquid. Okay. So solute which is always present in less quantity and solvent which is always present in more quantity. Here it will changes its physical state. This one will not change its physical state. Clear?
Every time solute will not change.
Sorry?
Every time solute will not change.
Every time solute will not change its physical state. Solute will change its physical state. Lemon juice? Okay. So actually, you are saying in that way, liquid and liquid. Okay, but it is getting completely ionizing and dissolving, right? Okay, in that terms, fine. So what happens in this is the dissociation also there. So it's completely getting ionizing. So in that, you're saying the liquid to liquid, liquid to liquid. So that is a different case. I'll be saying an example. There is a table column for that. Okay, just make sure to note this thing. I'll say that thing also. Okay, fine. And there is an explanation for that thing also. I'll give that thing. Okay. So now I'll give you a list of compounds. Okay, just try to say which one is a solute and which one is a solvent. Okay. Yes. So the first one is brine solution. Which one is a solvent and which one is a solute? Brine solution. So brine solution is nothing but NaCl in water. Correct. So this will be your solute and water will be your solvent. Okay. Yes. Second one, aqueous copper sulfate solution. Copper sulfate is your solute. Aqueous means water. That is your solvent. Third one, blue withdrawal. What is blue withdrawal? What is the form of blue withdrawal? Copper sulfate dot 5H2O. So this is a salt in your laboratory? Test tube. Drop some quantities of copper sulfate in a test tube. Heat it. Okay. Once after 10 to 20 seconds, once all the water molecule, this 5H2, when it is removed, means what happens? It will become white in color. When it loses the water molecule, means the color will be getting changed. It will be white in color. The presence of this water molecule, only this copper sulfate is actually blue in color. Okay. So this is a solid salt. So which means your water is present in less quantity and your copper sulfate is present in more quantity. So solute which is present in less quantity, that is solute, right? So here your water is solute and your copper sulfate is the solvent. Correct? So what is the formula of gypsum? S-block elements. Last year I have taken S-block elements. Everyone is completely sick. I do remember. Plaster of Paris. Plaster of Paris is calcium sulfate hemihydrate. CaSO4. Very good. You are right. Calcium sulfate. 2 molecules of water. This is your gypsum. Okay. So this is a salt. Gypsum is a salt. Where gypsum is used? What? Hey, gypsum is noise layer. What? Noise. That is plaster of Paris. Gypsum actually used in cement. In a manufacturing process, in cement, no, actually, with the addition of gypsum only, the hardening time of cement, that is the hardening package, that is getting reduced. Okay, they are just, in the wall when they are applying the cement piece, after a certain time only it is getting hardened. The delayed time is only because of this gypsum. Okay, so this gypsum is a solid salt. Okay, so here your water molecule will be less quantity. This will be your solute and this will be your solvent. Okay, now another one more important thing. Another one more thing. Finished with this one. Okay. Now I'm taking, if there is an equimolar solution of your ethanol and water. Equimolar means same. So which one is your solute? Which one is your solvent? Who said an instant reply? Say. Equimolar solution of ethanol and water. Come on. Ethanol is a solute and water is a solvent. How you are saying this? Good. It's physical chemistry. Don't go to halogens and halogens. Here there is a thing called equimolar. Mole. Anything you can just anything is striking your mind? Mole. Mole concept. So you have to determine the moles, which means what is mole? The amount of the substance you can measure, right? How much amount of substance is there you can measure, right? So you have to determine the molar mass, that is the molecular of these two compounds, and see which one is present in less quantity, that will be your solute. Which one is present in more quantity, that will be your solvent. So for ethanol, what is your formula? C2H5OH, and for water, H2. C2 means 24 plus 5 plus 1 6 plus oxygen 60, 46. So this one is 2 plus 60, 80. So this will be your solute, this will be your solvent. So this is present in less quantity, this is present in your more quantity. Correct? So always do remember, equimolar means only you have to take this thing. If the word is not mentioned in equimolar means the concept is different. Okay. So equimolar means whatever it might be. If it is 108 into 108 means by simple ratio it is 1:1 only. how we have to do? We have to take in terms of moles. We have to calculate the amount of substance present in it in grams. Take your molar mass. So these are all the possible things to determine your solute and solvent. Okay. So do remember your solute is always present in less one. Okay. So now coming to the next one, types of solution. Actually, this is a simple one. Shall I just explain it by verbally? Shall I explain it? So, okay, I'll make only one column as solute, your solvent, and your solution. And certain examples. This is the status in your book itself. Okay. So, if I'm taking my solute as a solid, okay, and my solvent is also a solvent, my solution will also be a solvent. Now you can ask me the question, if my solute is solid, solid is solid, how this solution will be a solid? Say for example, if I am taking liquid and solid, my solution also is solid. So here your doubt will be arising. Why should it be always solid? If it is liquid and solid means liquid, why can't it be a liquid? Correct? Because this solution always depends upon the physical state of the solvent. Because that will be present in more quantity. Okay. So can you see an example of solid?
Yes.
Right.
Ice powder.
Baking powder and tar. So
Ice.
alloys. Okay, that is also right. So you're saying that is also solid powder. This is also solid powder. Okay, fine. So the best example is solid in the sense you are just saying we have to take the higher efficient. So alloys. So alloys means we can say iron when it is mixed with chromium and nickel, it will be stainless steel metal. Iron when it is mixed with carbon, it will be quite hard. Brass, it will be like copper and tin. Okay, so bronze. So we can say very good examples alloys. Next one is liquid and solid. Liquid and solid. See, your solid is in major quantity. Huh? Gypsum. Okay, fine. So you can also take in blue vitriol. You can take another one more interesting thing. Amalgam. Mercury amalgam. Mercury is a liquid metal. Correct? And you can take any solid form. When it is combined, you will be saying yes. When it is amalgam. When a liquid metal is mixed with any other metal. Okay. So the best example is amalgam. And you can take also the gypsum and blue vitriol also. No issues. And here, gas with solid. So the physical state of solid. Gas with solid. So you are saying about cake. Okay, cake. So in cake, you are saying the carbon dioxide gas will be coming out from the cake, like it will be access that thing. You are saying in that form. So still any detailed explanations? Gas and solid. I'm asking the efficiency like solid should be a metal in that form. Okay. Have you ever? Yeah, I have thought this thing, right? Your conversion of your unsaturated compounds into saturated compounds. Your double bond into single bond. What is a catalyst you will add? Correct. Platinum, nickel, palladium. With that, another one more gas. Hydrogen gas. So your platinum, palladium, nickel is a solid. Your hydrogen is a gas. So what will do that thing? This is the reaction. Okay. So your alkene, when you are adding platinum, palladium, nickel with the hydrogen gas, what happens? Your hydrogen will be added on the surface of this alkene, and your double bond will be converted into single bond. Your unsaturated will be converted to saturated. What this hydrogen will do, and what these metals will be just doing here? Yeah, these are all D block elements. So what happens in the sense? These metals will be having a larger surface area, so will be absorbed example is hydrogen gas in platinum, palladium, nickel. Next one, solid and liquid. As I said, our first example. So here see solid is your liquid. So solution will also be liquid. So it will be salt or sugar in water. And liquid in liquid, as he said, liquid and liquid, it will be also liquid. Okay. So it will be ethanol plus water. See here also the lemon juice. Okay, you said no, liquid, liquid, liquid. The lemon juice will also come. Sometimes it won't change the physical state, but the particles will go and attack in the intermolecular spaces. No, that is there, no, that is it. Okay. Another one, gas and liquid. Very good. Who said that? Another one more example, any other example? Aquatic organisms. Aquatic oxygen in the water itself, they are just having the oxygen, no. So aquatic organisms. Next one, solid in gas sublimation. Any examples? Camphor. Very good. Camphor, naphthalene balls, iodine. There are examples. Okay. Who are that? Anishna, I'll give a break. Okay. Solid in gas. Nuclear gas. Iodine. Iodine, camphor, naphthalene or anything. So liquid in gas. Any example of liquid in gas? Your moisture or your humidity that is present in your atmosphere. Iron, when it is converted to iron oxide or copper, when it is exposed to atmospheric oxygen, the green patch will be formed on the surface, right? So what happens means when the carbon is exposed to the atmospheric oxygen, we take oxygen, carbon dioxide. For the green patch, you know, the green patch is responsible for the moisture H2. Have you anywhere got this reaction? Copper, okay, when it is exposed to atmosphere, what happens? நான் சொல்றது புரியுதா? இந்த மாதிரி ஒரு copper rod இருக்கியா? When you are just exposing the atmosphere, in this room there is oxygen gas is present, carbon dioxide gas is present, some amount of moisture is also there. So the moisture also react, and finally after a couple of weeks you can see a green color patchy layer will be formed. What is the reason? Moisture H2O. That is the reason for it. You know this reaction, right? H2O and carbon dioxide forms copper hydroxide, and your this is the formation of the green patchy layer. Okay, don't need to write it. It's not in solutions. Just for your general information, and just okay for balancing this. Okay, so this is because of the moisture H2O. That is your liquid plus gas. And next one is gas. What is the example? Gas. That is nothing but your air. So this air is a mixture of oxygen, nitrogen, carbon dioxide, helium, hydrogen. Everything is present here, right? So this is an example of. So everywhere I have explained about the solute, solvent, solution, and some examples. Okay. LPG is nothing but gas. Methane, ethane, butane, propane, everything is compressed, liquefied LPG, petroleum gas. Okay. So now moving to our next one, strength of the solution. Yes, anything? What? HCl gas. HCl gas is an example of that. But there is only one gas is present, right? There should be a mixture of gas, right? Oh, hydrogen and chlorine. But hydrogen and chlorine, it's not as such present, right? By electrolytic, by only the hydrogen and chlorine will be properly we are just moving into the chapter. Any doubt? Solute and solvent? No, because in your questions they'll be giving this is a solute, this is a solvent means at that time do remember only one thing. Lesser quantity solute or any salts solute. Maximum your solution will be occupying the solvent. Okay. Okay. Strength of the solution. What is strength of a solution? Amount of solute present in the solution. That is your strength of the solution. So you can say in other words also amount of solute that is resulting 1 liter of a solution. Okay. So here my another question is, okay, just write amount of solute dissolved in 1 liter of solution. Okay. So here my question is, sometimes the solute will be solid. Sometimes the solute will be liquid. Sometimes it is present in gaseous form. So it is quite, by conventional method we can't predict or we can't say how the strength of the solution will be. So scientist actually he said by many terms. Okay, he actually suggested many concentration terms. By that only we are going to derive the strength of the solution. Okay. So first one is, do you know the unit? So unit is amount of solute. So you can say, mole per liter. How much mole per liter? Just say. How much mole per liter? Okay. What you said mole, right? When will you take the mole as a unit? For a substance, you'll be taking it in grams. I'm saying when you are taking moles as a unit. Concentration. How you are saying concentration? Where you will be taking concentration? Oh, you're saying unit. Unit is concentration, right? Then why you said moles? What happened? I can't hear what you said. Mole is a unit. The mole is itself a unit. Say for example, if number of moles of solute is there, it is a unit called mole. Now what happened? No, don't drink water. Sit down. Already water is there, no? Cool water. Cool water. Why? Why you want cool water? After completion of the class, we can drink cool water. Okay. So mole is itself a unit. Okay. So here this amount of solute is determined in grams. This is actually in liters. So strength of solution is gram per liters. As you said, in some book, concentrations also used. Okay. So it is also said in concentration small c. Okay. So this strength of the solution is expressed by two ways. First one is by quantitatively, and second one is by qualitative. Qualitative, quantitative. Li T. Okay. What is mean by qualitative? What is mean by quantitative? Quantity is the amount. Then quality is your sitting in chemistry class. Okay. Quantity, quality, quantity. See, this quality means actually it can be said in two terms. That is dilution and concentration. What is dilution concentration? Okay. What is dilution concentration?
Dilution is
Dilution is
increasing the amount of
in dilution or in dilute, you're saying the solute will be less or less. Okay. So in concentration, the solute will be more. Say for example, you can say gulab jamun and rasagullas sugar syrup. Okay, everyone is getting tempting. Have you seen the gulab jamun sugar syrup? How it will be concentrated, because you will be adding a 1 bowl of sugar and you will be adding only a quarter, like 1/4. Okay, 1/4 of water. So there your solute is more and your solvent is less. Clear? Can you get my point? So what happens? You are adding sugar in more, and you can see the liquid will be more viscous. It can't easily flow. Correct? But in rasagulla, when you're just squeezing the rasagulla, you can see it can easily flow, because there the sugar is less and the water is more. So that is dilution. Dilution means your solute is less, okay, and your solvent will be more. Here it is quite upside down. Your solute is more and your solvent is less. So what is this? Is actually quality. Now, why are this quality? We can't find the strength of the solution. Why? Any? Okay, I'll. Huh? Okay, so here, exactly. Very good. So let me say an example. Have you seen a paracetamol in tablet form? In tablet form, when you're just taking, they'll be like 650 mg, 500 mg. So for elders, if you're just taking the paracetamol, means you can assure we have taken 650 mg of paracetamol. But when you're just giving the paracetamol syrup for small children, okay, so there'll be paracetamol with sugar syrup in a syrup form. So at that time, when you're just giving the syrup to the children, we don't know how much amount of paracetamol has gone into their body. Correct? So at that time, we don't know what is the process happened. So for this kind of thing only, this dilution concentration quality is not mentioned in strength, and we are moving to the quality. We are moving to the quantity. For these kinds of things only, we are moving to this quantity. So strength is always expressed by quantitative. I சொல்லணும்னா சொல்லிக்கோங்க. பேசுறதா பேசிக்கோங்க. கண்ணாலேயே பேசிட்டு இருக்காரு. Okay. Okay. So the strength is always expressed in terms of quantity, because here there is many things to overcome. So it is expressed in quantity. Now my question is, how it is expressed in quantity? Gulab jamun. Molarity. Oh, normality, formality. Okay, so there are certain concentration terms with which we are going to find this strength. Okay, so this. So this quantity is expressed in many ways. So first we are going to see mass by mass percentage. Okay. Second is by volume percentage. And third one is mass by volume percentage. Okay. So this is the first three things we are going to discuss here. So first one is mass by mass percentage. So here, see, both of them are mass. If both of them are mass, in the sense both of them has been measured in terms of grams. Correct? So here, if you're just taking for the solute, okay. So if you want to see solute, mass of the solute is amount of solute in grams divided by total amount of the solution in grams into 100%. Okay, or into 100, anything, that's fine. Now, volume by volume is both in liters. Correct? So mass will be always in grams. So this is both in liters. Okay, so how can you write that thing? How same thing I think.
Instead of terms, let us.
So if I'm taking volume of a solute is equal to similar applies for solvent also. We can put solvent, amount of solvent divided by total amount of. See the solution is equal to solute plus solvent. Correct? You want to write that thing also. So as a solution means it is solute plus solvent. Okay. So volume solute is equal to volume of solute in liters. Actually, see, we will be doing this experiment at the laboratory level. Milliliters is fair enough. Don't need to measure liters. For commercially only we need liters. So milliliter is enough. Volume of solute in liters divided by total volume of the solution. So this is an into 100. So third one is mass by volume, which means gram and liters. So here can say, so just taking for a solute, it will be amount of solute in grams divided by total volume of the solution in liters into 100. Clear with all these things? Mass by mass, volume by volume, mass by volume. Now, shall I give you here, right here? Clear? Milliliters. Okay, so now another one more thing. Always see if you're just taking a solution, solute and solvent combined together and it makes solution 100%. It can be your 60, 40 or 70, 30, whatever it may be. The solution at the rate it will be only 100%. Yes, clear. Do you remember this thing in your mole concept? It's so say the formula for solvent. Either yes or no. You're the one said yes, right? So this solute, okay, plus solvent is equal to solution, which will be 100%. Okay, so from this thing, if you want for the formula of solvent, it is equal to 100 minus solute. So likewise, you can do it for your solute also. So solute is equal to 100 minus solvent. This is also another formula. So now I'm going to give you kind of just a little thing. It's not like a question. If you are provided with 10% of glucose solution. Okay, so glucose is a solute or a solvent. Solute. So your water will be the remaining. The liquid will be your solvent. So 10. So your glucose will be in grams. Correct? So just can calculate by which formula will be applicable there. And 10% of glucose solution. Okay. Now carry over this thing. See, first one is this is your solute. Correct? So solute in the sense you can find your solvent's mass. Correct? So if solute is 10%, 90%. So substitute in your formula. So what will be your answer? 10. Purichada puriyaliya? Who got it? Who doesn't get it? What you got? See, 10% of glucose. This is your solute. Okay. So if this is your solute in the sense, solute is 10% each. So we know the formula. Okay. So solvent is equal to 100 minus solute is 10, which means 90%. Okay. So now apply it here also. So what will be the thing? It will be 10 divided by 100 into 100, which means 10 is your answer. Clear? புரிஞ்சதா? என்ன புரியல? Clear-ஆ? Okay. This is amount of the solute. 10% glucose. Total volume of the solution 100 into 100 is there in the formula. Let's try the things and take. Is your answer? See, this glucose is actually present in a kind So you're just adding your glucose in a form of powder. So that will be in grams, and your water will be in liters. So mass by moles. Okay. Okay. So this mass by volume, no. This term is the one which is used in the format, like in pharmacy, in medicine industry, they will be using only this thing. That is amount of the solute that is dissolved in your water. Okay, that is in liquid. Correct. So if you're just taking your paracetamol solution, your paracetamol which is mixed into the water. So mass by liter. Your paracetamol as a solid and your solvent will be your liquid. Correct. So this mass and volume will be used in the pharmacies and in medicine. Clear with these three terms? Okay, just know the formula. There will be no kind of problems will be asked from this. Okay, so now we can get into the molarity, molality, and everything. School முடிச்சா இங்க வந்து தூங்குவீங்களா எல்லாம்? Okay, so now we are going to the first method to express your strength of a solution, molarity. Okay. What is molarity?
Number of moles presented
1 liter of the solution. So, number of moles of solute that is present in 1 liter of the solution. Okay. So, here is this formula more precise? Volume of solution. So, how you can express your number of moles? So, what is the formula of moles? So, moles is nothing but given mass divided by volume mass. Molar mass. So, given mass divided by molar mass. What is molar mass? Huh? So, actually, molar mass is nothing but your molecular mass or atomic mass. Okay. So, say for example, I am taking H2O. So this H2O will be having 280. So in molecular mass, it will be molecular mass is denoted by the symbol mu. Correct. So if you want to take it in molar mass, it can be denoted by grams. That is the difference. Correct. This molecular mass will be denoted in mu. Here it will be in grams. So now actually we need to represent this here. So number of moles of solute is equal to given mass of the solute divided by molar mass of the solute and how this 1 liter of the solution can be expressed means sometimes it can be milliliters also. So you can write this thing as given volume of the solution in milliliter divided by 1000. Okay, so now the given mass divided by molar mass into 1000 divided by given volume of the solution. Okay, so this will be in grams. Correct. Now can you do the problem? Yeah. See, say for example, 1 liter is equal to 1000 milliliter. Correct. So if they are given 500 milliliter means keep it as 6. That's how I converted. Okay. So now can we do the problems? This is your formula for molarity. So can you see the unit for this thing? See, yeah. So this can be the unit of this mole is as such moles. Okay. So it is 1 liter of solution divided by liter. So it will be mole per liter. Okay. So unit of molarity is mole per liter. Okay. Now, molar mass of solute. say for example, if 40 grams of NaOH is there. Solution. Sorry. Okay, fine. So now you're solving the problem, sir. Molarity. Okay, so anyway, see, for in molarity, your solvents should be always in a solution form because here it is present in liters. Okay, see, please. Repeating la. Okay, okay. Okay. So now I'm reading a question. Okay, so here in your molarity, always your solution should be in solvent so that they have been given in liters. Okay, so I'm reading a question. If 20 gram of alcohol, okay, its density is 0.8 gram per cc, is added to 80 gram of glycol, its density is 1 gram per cc. What is its molarity? How will you find this thing? Any idea? No idea? What is your okay? Say. I'll write on this. Okay. So what is the formula of density? Mass by volume. Okay. So mass by volume. Okay. So I'll write a question. $20 grams of alcohol. So this rho is nothing but density is represented by rho. Okay. 0.8 gram per cc is added to 80 gram of glycol, rho 1.4 gram per cc. Yes. Find molarity. As I already said,
Which alcohol? Which alcohol?
which alcohol? We take a simple one. Anything you are going to take a molarity. Okay, so now see in your formula, molarity is given in liters, but here take a look, it is written in grams. So what will you do? You can understand the thing. What will you do? Mass by volume, then density is equal to mass by volume. So what will you do here? So here the density what they have given 0 point. So first we can do it for alcohol. That is for simple methanol. Okay, CH3 voltage. So here it is 0.8 gram per cc. Here there another one more thing is there. I'll let you know. And what is the mass they have given? They have given 20 grams. Okay, by volume. Okay, so what is the cc? Cubic centimeter. We can represent this as centimeter cube, right? So, do you know the conversion in mole concept? 1 milliliter is equal to 1 centimeter cube. Now, 1 yes, okay. All yes, I want. Don't know. Okay, now you just remember this thing. Okay, 1 milliliter is equal to 1 centimeter cube. If you are not having the kind of thing, you're not remembering these, go and check your mole concept chapter. There will be a conversions. In your essay unit, there is a big tabular column. Many conversions will be there. In that conversions, 1 milliliter is equal to 1 centimeter. Okay, so this cc is nothing but cubic centimeter. So this can be written as centimeter. 25. Okay, so like 25. So volume we got 25 ml. Okay, so now do the similar thing for your glycol. Okay, so it is given in grams. Convert it into milliliter volume. So I'll be doing here. Better you can do on your own. Okay, so density is equal to again mass by volume. Here the density is 1.4, right? So 1.4 gram per milliliter, which is equal to mass is 80 divided by your volume. Divided by volume. So what happens here? Your gram and gram will get cancelled. So volume is equal to 8 divided by 80 divided by 1.4 milliliter. So what is the calculation for this thing? 8 divided by 8 divided by 8 or 8. Okay. 80 divided by 1.4. 57.1. So this is 57.1. Correct? So here, see, we have taken this alcohol and glycol. Okay. So here we have taken our solute and solvent. So now we want the total volume. So now solution is equal to solute plus solvent. Correct? So solute which is present in less quantity, this is the thing, 25 ml. Solvent 57.1 ml. So what will be the answer? 25 plus 57.1? 57, 25. 2 balance 1, 6, 7, 8. 82 milliliter. So now we got everything. Correct? So now you can apply in the general formula. So for molarity, given mass of the solute divided by molar mass into 1000 divided by
Why are we finding volume of solute?
volume of, yeah, because your problem itself we will be finding what is the solute. We want what is the solute. See,
We need number of moles of solute. We need number of moles of solute.
Yeah.
So why is volume?
We need to find the molarity on research.
The number of moles.
So here for number of moles of solute, so you are asked retaining the solute. So okay, in this formula, given mass of the solute by molar mass divided by total volume of solution is there, no? Total volume of solution. For that we are just finding this thing, okay? Okay, can you follow this thing? Yes or no? Okay, so divided by 82. What is our given mass of the solute? Solute which is present in less quantity. This is 25. That is nothing but your alcohol. So what is the given mass? 20. 20 divided by molar mass. So it is for carbon 12, hydrogen 3 plus 1 4, oxygen 60. So 20 plus 32. 20 divided by 32 into 1000 divided by 82. So this is your answer. Calculate everything. 6185. 20 into 1000. 2000 divided by 42. 7.6. So the unit is moles per liter. Or else you can write it in this form 7.6 capital M that represents the molarity. Everyone understood this problem? Clear with this one? Okay. So first of all, you understood the question. See, in some questions directly they will be given the milliliter. Sometimes they will be given in terms of grams. At that time, we need to convert the grams to milliliters. Okay, so what happens? You will be using this term called density. Clear with this one? Are you doing the second one? Second problem? Wait, everyone needs to say yes. Everyone got this problem? Clear? Can we go for the next one? Shall I have this one? Break up. Okay, go. 2 minutes break. I'll write it. Okay. Solution editor. Go. For each concept, minimum of 5 problems shall be worked out. Everyone. Okay, ba? Huh? So 6 classes it will take. Okay, ba? Huh? Fee is not deleted, that's fine. But a solution for 6 classes, okay, ba? Sure, 100% sure P block is deleted. But they are saying that again they are going to add it. No. Shall I write the second question? எனக்கு நான் தான் போய் Today can you take 2 to 3 problems to home or you can solve here also. Yes. Yeah, I said 2 minutes, man. Still you're drinking water. Huh? Within 10 minutes, this session itself will be getting over. He is saying not to write the problem. See, first of all, read the problem and then try to solve it. Okay. I'll write another problem also on top. Okay. Huh? See, what are the things are given here? 0.5 molar. Do note the term 500 ml of solution. And they are given sodium acetate. Molecular mass of sodium is 23. Okay. So I'll write one more problem. What are the things they have given? What is the thing is missing? Which means in moles of solute there is given moles, given mass divided by molar mass. So given mass is missing, right? That's it. Try it. I will also solve it. Okay. Another one more question. First one answer.
1.6.
Wait. What is your answer?
1.6.
No. 41. No, almost right. Hey, here, look at here. What is the 0.5? Molar mass. Molar mass. Who said it's molar mass? How is molar mass, man? See, here is your compound is there. No, this is your molar mass, right? Then they have actually included your molarity here itself. See, molarity is equal to, don't make silly mistakes. Given mass divided by molar mass into 1000 divided by volume of your solution. Okay. So here they have disclosed the molarity of 0.5. Correct? They have disclosed 0.5 molar means it's your molarity. Correct? So 0.5, you don't know your given mass. So your given mass, what is the molar mass? 23, 24. Okay, fine, I'm writing. 1000 divided by 500. So now 0.5 into 500 into 82 divided by 1000. What is the calculation? So now 0.5 into 5 into 82 divided by 20.5. This is your given mass. Everyone got this one? Yes, sir. Sorry?
Second answer 0.
Sorry?
Second answer 0.4.
This is 0.4. This is 20.5. Why you are just converting into liter? Because here it is 500 milliliter. Given volume of solution is milliliter, right? Okay. So second one is 0.4.
This one is
0.4. So I think it's very much direct, right? Given mass, molar mass of NaOH is 23, 16, and 140. 40 into 1000 divided by 250. It's a direct one. So solve it. It's 0.4 moles per liter, or else you can write 0.4. Another problem. I'll be giving in the next class. I actually forgot to bring. Yes. I'll be giving more problems in next class. We can move to the next one. Molality. Okay. So far you have learned about molarity. Now you are getting into molarity. See, this molarity will be represented by capital M. This molarity will be represented by small m. Okay. So what is the? There is actually everything is similar. But there is only one kind of alteration. What is that? Mass of solvent. Mass of solvent means how can you represent that thing? So you said it's 1 liter of solution. Here, 1 kg. Okay, 1 kg of solution. Solvent. So directly we can write the formula and go for the problems. Okay. Molarity is equal to given mass divided by molar mass into 1000 divided by divided by mass of the solution, mass of the solvent in grams. Okay, mass of the solvent in grams. So what will be the unit for this one? Mole upon kg. So first problem. See, just a slight modification. There it is in liters. Here you are taking in grams. That is your solvent, their solution. Now I am giving the question which is related to density. Okay. Find the molarity of a 500 ml aqueous solution of 40 grams of NaOH. When the density of solution, see this is density, okay? Density of solution is 1.2 gram per cc. See, here they have been mentioned in milliliters. Okay, so here your question is the mass of solvent in grams. So you need to convert this milliliter into grams. Okay, so again use the density is equal to mass by volume formula and carry over the problem. I'll be doing here also. So density is 1.2. What's that? Okay. 1167. So what is the answer for the density? I mean, like, there your mass will be obtained. What is the answer for nothing a mass? Huh? Okay, 600. Okay. So you made that thing solution is equal to solute plus solvent. You have done that thing. So what is the answer for that thing? For solvent, 1.7 is right. 1.67. So 1.7 on the whole. That is right. Okay. So it's a 1.17. 1.67. Okay. You got this answer. So what is the mass here? It is 600. 600 grams. So after that, what you need to do? Huh? 1 mole. So directly you have dropped the 600 in the formula here. How 560? Solution is equal to solute plus solvent. So what you done here? என்ன பண்ணீங்க? Exactly, your solution is 600. Okay, and your solute is actually here. You can see question it is 40. So that gives you your solvent. So 560 grams. So substitute here. So it is like given mass is 40, and for actual masses that is also 40 into mass of 1000 divided by your mass of the solvent is 560. Okay. 1.7. Yeah, why you are saying 167? Okay, everyone got this thing. You understand everything? Everyone understood? Any doubt on this problem? Definitely a question will be asked from your concentration notes. Only these kinds of questions is possible. With density or directly they will give everything. Okay? Another one more problem. Clear up this thing?
Yes, ma'am. Yes, ma'am.
Got it? Any doubt? No? Twenty grams of 20 grams of C2H4O2 is added in water to form a solution. Form a solution of 100 gram. Find the molarity. C2H4O2 24 plus 4. Who is this much very fast to calculate the molar mass? 60, yeah. Okay. It's added in water, everything they have given. So molarity. Do it. So 20 divided by 60 into 1000. Only you have to find the volume of or the mass of the solvent in kilograms. It's a very easiest one. So you need to find it for solvent, right? So first one is in solution. Solute the solvent. So in solution they have given 100 grams. Okay. So solute is 20 grams plus solvent. So which means your solvent is 80 grams. Now we can substitute in the formula. So molarity is equal to very good 20 divided by 60 into 1000 divided by 80. Cancel, 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 cancel. So 4 points. Correct. 4 point. You guys are making my job. 4.16 moles per kilogram. So this is your answer. For molarity, see always if they have given solution means don't take this 100 gram and substitute it. Okay, because in our problem mass of the solvent. Okay, mass of the solvent solution whatever there. Just remember the formula and find whatever the given term solvent means. Find the solvent and then substitute. So in molarity it should be solvent. In molarity it will be solution. Okay. So next one is mole fraction. So we can see in this class or next class. Want another problem? Here. I'll bring the book next week. Here I have solved only some problems. So shall we go? I'll bring it next week. Sorry. Okay, I'll bring it. So far we have solved 6 to 7 problems. So next one is mole fraction. Shall I take or you want to discuss? I will take. What? 6:30, no, 3 minutes matters. Okay, what is mole fraction? Just say the correct definition, I'll let you go. Solution. Okay, number of solutions present mole wise. Okay. So yes, your formula is right. How it can be denoted? XA plus XB. You're right. So I won't leave you. Okay. I'll leave you. See, Saturday is a test, right? Be sincere, study for your test, and write it. When are you going to submit your 2 assignments? Submitted. What about the next one? Monday. I said no, Monday I'll give. Oh, Monday, Saturday you're going to write the test, right? So please submit it tomorrow, okay? Yes. You can leave. It's 6:30. Bye.
Yes.